Ratio test, RT, is very convenient. So we learned divergence test. We're going to check the new limit this time. In divergence test, we were checking limit of an go to infinity. Now we're going to check the ratio, and that's where the name comes from. Ratio will be every next term, a sub n plus 1, over the previous term, a sub n. We don't care about the signs, so let's put absolute value, not to care about negative signs. And we call this limit L. And based on what L is, we're going to have conclusion. If the best one is if L is less than 1. If L is less than 1, it means every ratio gives us a fraction, right? So it will be like 1/3, 3/4, whatever is less than 1. If it's a fraction, then the series converges. Then the series a sub n, and I will not even write down from where to where, because in this case it's a theorem, we don't need details. Converges. And then I will put in the parentheses absolutely, and I will explain you soon after 2 examples. What does it mean? Absolutely. It's a pretty important term in mathematics. Converges absolutely. If the ratio is greater than 1, like 4/3, 10/1, that the numbers are getting bigger because we're checking ratios. So every time we check, then the numbers are getting bigger. Let's put or infinity. That gives you a hint. Diverges. Then, let's put comma. Absolutely. Then diverges. And then if L is 1, then not another info, use another test. No info, use another test. And in general, we're supposed to teach you like 10-ish tests in this chapter. But you guys, lucky in this school specifically, they skip most of them. We're only going to give you ratio test, integral test. But most of the stuff on the exam is a ratio test. But in the previous University of Utah, I was teaching all the tests, and then on the exam, you give the series, and you guys decide which test to use. And it's so much time consuming because you have to keep checking different ones. The different suggestions how to do it. So, okay, let's summarize. This is a ratio, a sub n plus 1 over a sub n. It's a ratio. That's what it's called, ratio test. If the ratio is a fraction, what kind of fraction? The good one, 3/4, 1/3, converges. If it's a fraction that's greater than 1, then the ratio gets bigger and bigger, diverges. 1, we don't know, use another test. Example. Oh, I was very excited last time, I can see that. Everything is super fat. And now please concentrate today, right now. I will review something for you which we expect you to know. So maybe you should concentrate, because this is a good chance to check it out. Do you remember what is n factorial? Don't worry if you don't. Some schools maybe skipped it, maybe your teacher got sick, and now you feel awkward about it, but I will review it for you. So 1 times 2 times 3 times n and go, and keep going till n, or n times n minus 1 times n minus 2, and so on till 1. So it's a product until n. Very nice notation, n factorial. For you to know, it's the fastest function. So I was telling you exponential function is the fastest. N factorial is faster than exponential. And then n to the n is the fastest one. So n factorial, factorials grow like crazy. So when people say, oh, it's exponential growth, factorial actually grows faster. More examples. How do you work with factorials? So what does it mean to have a ratio? Everything is fat. The ratio n plus 1 factorial over n factorial. Check it out. The first one is 1, so let's do the second one first. The denominator is the one I just told you. 1 times 2 times 3, and keep going, times n. This is usually the notation. Usually the 3 dots are going in the bottom. What does it matter? The top is 1 times 2 times 3, keep going till n times n plus 1, right? Put parentheses, that's important. That's important. So we have products this time. Since we have products, all of these cancel out. 1 over 1, 2 over 2, n over n. And usually people show it like so. all the products at the top cancel out with products at the bottom except one. N plus 1 stayed because it was extra. So the answer is n plus 1. That is the answer of this ratio. So the tail stays. Does that make sense? The tail, whoever is bigger, that tail stays. Maybe it's 3 terms. So if it's n plus 3, what's going to stay? N plus 1 times n plus 2 times n plus 3, and so on. So that's the review. Let me put it in the flower thingy. So factorials, maybe I should write it down. Okay, very interesting thing. I was teaching this class for 5 years at ASU, maybe 4. And I was saying factorials all the time. Because in Russian, do you know how we call factorials? We call them factorials. Factoriali. So I just say the way I learned it, right? Nobody said anything for 3 years in a row. For 3 years, nobody was brave enough to say anything. Until I was teaching on Zoom, because we had COVID. In Zoom, it probably was hurting people's ears so much that finally someone brought it up and said, Professor, you're kind of saying the factorial weird. And I never noticed it. It's not like it's very obvious. Honestly, it's not somehow. So I really, how do you say factorials? And they're like, well, we say factorials. I'm like, well, that's what I say. And I'm not arguing, I'm trying to learn. So I asked them, maybe someone suggested in chat, maybe she should say it slower. So I said, okay, factorials. So everyone started screaming, no, that was a bad idea. I'm not even making this up. That was a very interesting conversation in my calculus 2 class. People started screaming, no, that was a bad idea. Let not her say it slow. So I'm like, okay, so factorials. And people taught me, it's factorials. Now it's so hard to switch because I was saying it for so many years. Do you know how hard to switch language? So wrong. So you will hear me saying both at some point. So factorials, if I say too fast, and I do not change. But factor with A, that should be correct. So for you to know. Somehow that became a joke. And someone in the final exam did write to me in letters, spelled factor. Which was not very nice. But that was a good joke though. So now you know, remember that. If your parents ask you when they visit you, what did you learn in your class this week? Tell them that you learned factorials. N plus 9, because it's correct in my language, so I don't see a big deal. Anyway, n plus 9 or n factorial. N from 6 to infinity. You see, I can start from anything. We keep starting from 0 or 1, but actually it can be anything. What do we want to do? Example 1. We want to check converges or diverges. Just let's do converges or diverges, question mark. Just like, of course it should be more professional. I should say check or find if the series converges. So what we're going to do is, let's first review divergence test, because I told you, don't waste your time on a test that was a series, right? Don't waste your time if the series blows up, diverges based on the divergence test. So let's do like in blue, it's like step 0. We do recommend to check it, or else kind of like, why are you wasting your time? Let's check step 0, divergence test. And people actually do that. That's true, divergence test. It is pretty applicable situation. Divergence test says, let's check the long run limit. So the tails at infinity. Unfortunately, you remember, well, hopefully you remember, n factorial is super fast, I just told you. Faster than n plus 9. So the answer is 0. But 0 doesn't give us any info. No info, use another test. No info, use another test. And that's what I just taught you. I just taught you a new test. So that's where it comes in. And we have more tests. We have interval test, this comparison test, and so on. So now we only know one more test. This is not a geometric series because there's no to the n part. There's no common ratio, common factor, you see? So we don't do geometric series here. If you see factorials and exponential functions, that's usually a ratio test. So let's do ratio test for the very first time. I will teach you how to do it better and faster than in general. So ratio test checks the ratio, the next term over the previous term, absolute value, so we don't care about signs if there are any negatives there. Equals, and now check it out, limit I don't want to have a fraction of a fraction because that's it's going to be, right? It's going to be n plus 9 over n factorial and blah, blah, blah. I don't want to have fraction over fraction. So what I usually teach students, you write down one fraction and then multiply by the flipped another one. That's what I'm going to do. So first of all, n plus 1. Everywhere you see n, you're going to plug n plus 1. Let me zoom out and then do it together with you. N plus 9 becomes n plus 1 plus 9. If you use colors or put in parentheses, that will be very visual explanation. Over n factorial becomes n plus 1 factorial. There's a mistake here. Parentheses matter because 1 factorial is not the same as n plus 1 factorial. Instead of dividing by a sub n, I will multiply by the reciprocal because it's just convenient this way. So you just flip the original fraction. This is the first step. So what I did is, I'm explaining here. This was a n plus 1, too fat. A n plus 1 times 1 over a sub n. That's what I did. It's easier this way, it's faster, and we're checking in the long run. So we're checking the behavior of the ratios. That's why it's ratio test. All kind of ratio. 5th term over 4th term. 65th term over 64. 100 over 99. If all of those terms gives you a fraction like 3/4 or 1/2, it shrinks. So it converges. If all of those ratios in the long run gives you something bigger than 1, it blows up. So that's why this ratio makes sense. Now we start working with those amazing factorials, right? So let's do limit. N goes to infinity. I recommend to collect the terms that look alike. Collect the terms that look alike. So n plus 10 comes from the first term. And then there's an n plus 9 from the second. Collect the terms that look alike. Exponentials with exponentials. Factorials with factorials. Polynomials with polynomials. It will help you a lot. Keep absolute value even though it doesn't need here, but it's just nice in case you missed something. N factorial over n plus 1. Absolute value is not needed here because n factorials are positive, and n plus 10 is also positive in the long run because n goes to infinity, so at some point everything is positive. Now, oh, did I mess up? Did you notice? No, it's good. So did you see how I collected the terms? Finally, let's simplify, and this is where students stuck, especially if you don't remember factorials and how to work with them. Don't touch n plus 10 and n plus 9. This cannot be simplified. We're going to just use the limit on that. But you should simplify n factorial, n plus 1 factorial. And I just did this example in blue color over here. The tail will stay. So, can you tell me what's the answer? N factorial over n plus 1 factorial? 1 over n plus 1. Do you all agree? Don't get distracted, people. 1 over n plus 1. Should I write it down for you or not? Let me write down 1 over n plus 1 and then I'll ask if you understand this. 1 over n plus 1. The tail stays, whatever the tail is. Who just blinked and doesn't understand what is happening? Did you just like drop the pen, pick it up? Yes? Yes, exactly. Your statement is correct. Let me rephrase what you said so people also have good idea what's going on. So what I did was n factorial. Let me see. So skip some space because we're almost at the answer. N factorial. N plus 1 factorial is 1 times 2 times blah, blah, blah times n over 1 times 2 times blah, blah, blah times n and the tail. What is the difference between those two terms? This tail cancels out, stays. 1 over n plus 1. The numerator is not 0. Do you understand that? Some students think it's 0. It's not 0. Canceling out means dividing. N over n is 1. 2 over 2 is 1. 5 over 5 is 1. 1 over n plus 1 goes to the answer, right? So hopefully that's explained. That's not the final answer. Now we find the limit, and this takes you to Calculus 1 class. Hopefully you remember some limits, because they will be quite everywhere in this chapter. N plus 10 over n plus 9, limit of that gives you what? No. N plus 10 over n plus 9. That gives you 1. But then also 1 over n plus 1 gives you 0. So 1 times 0 is 0, or the way you mention it. I like to explain it this way. And this part gives you 1 at infinity. This, let's not do equals, let's do goes to 1. This part goes to 0. 0 times 1 is 0. The answer is 0. Limits. The speed of functions will help you. I have videos on that. And the basic limits, I also have videos on that to review. For the first limit, it was ratio of leading coefficients. Or you can see it like you probably saw it, I think. The numerator has a power n. The denominator has a power n squared. N squared goes to infinity faster, so you're dividing by the biggest numbers, which gives you the smallest numbers, which is 0. The interesting part about the ratio test, we don't care it's 0. What we care, if it's less than 1 or greater than 1. That's actually more important. It's less than 1. So let me write down. This is L, and this is limit, that less than 1. Converges absolutely by ratio test. That's the answer. Converges absolutely by the ratio test. And I will tell you right now what does it mean to converge absolutely. What do you think about this? Not too bad. Yes?
Question. So if you change like the n plus 1 factorial to n plus 5, does that change?
No, the answer will be the same. Very good question. What if we have n plus 5 factorial? The fraction will be longer. It will be n plus 1, n plus 2, n plus 3, n plus 4, n plus 5. But the limit is still 0. So it will not change anything. Very good. But if you change the order, then it will change the answer. Yeah. Very smart. Very good question. More ideas? Don't get distracted, people. Yes? Instead of having this fraction over fraction, because this fraction should be divided by this n plus 9 over n factorial. So what I did, I just multiplied by reciprocal. Reciprocal means I flipped. Remember? So when you divide by 1/5, that's multiplying by 5. Oh, right after? Oh, no, I just collected the terms. This term and this term got together. This term and this term got together. That's my recommendation. Collect the terms that look alike, because then simplification goes well. And I'll show you in the next example why. Good questions, people? Make sense? Ratio test, usually students' favorite topic. So I'll be asking you questions for the next example. But before next example, let's do the definition. What does it mean to converge absolutely or conditionally? Please write it down. Absolute versus conditional convergence is pretty important in applications and so on. If the series is a sub n from 1 to infinity, then if the series converges with the absolute value, then it converges absolutely, or it's called absolutely convergent. If it converges without absolute value, then it converges conditionally, or called conditional convergence. So basically, absolute value matters. If it converges with absolute value, then it's called absolute convergence. Absolute convergence is a strong condition, which means, note, if converges absolutely, then it also converges conditionally. I think double L, yes. One is stronger than another. Absolute convergence is called a strong condition, because from that condition, the second one follows. So this arrow means follows. If, then. Because if it converges by absolute value, it also converges without absolute value, but not the other way around. So the second one is a weak condition. Strong versus weak. If series converges conditionally, it does not necessarily converge absolutely. That's why it's called conditionally. It converges with the condition that absolute values do not converge. Okay, I think whatever I just said sounds super confusing, which is typical. So let me see that you finish writing and I'll summarize. So like this is important. Conditional convergence means it converges with the condition that absolute value do not converge. Absolute convergence means it converges both with absolute value and not absolute value. That is the idea. That's why one is called strong condition and another is called weak condition. Absolute convergence means absolute value converge. Conditional convergence means converges with the condition that absolute value diverge. So let me show you this one. Let's get into more exponents. Exponents. Example 2. Example 2. What if you have a series? That's from your homework, to be honest. And something like this will be on the exam 3. And also I put this on the final exam. I always say it right away. This chapter goes to the final exam, mostly because students do really well on it, so I like to put it there. Students' law of ratio test. And I like to put it in a free response and multiple choice, so people do well in both ways. So if you check the divergence test, you actually don't really know the answer. It's hard to know. You have to use computer, what is going on here. So let's just go to the ratio test right away. Ratio test, I call it RT, ratio test. The ratio test says, let's check the limit of the ratio. L equals limit in the long run, so n goes to infinity. We're going to check all the n plus 1s divided by a n's. So all the next, over all the previous ones. Have enough space, so go to the next line. That will be pretty long. It's going to be a limit. N goes to infinity. Now, everywhere you see n plus 1, no, everywhere you see n, you plug n plus 1 for the first term. So I will color code it, but you can also try to do it with a pencil or pens. 9 to the n becomes 9 to the n plus 1. N plus 1 becomes n plus 2, right? Because it's n plus 1 plus 1, like so. 5, 2n plus 1 becomes 2n plus 1 plus 1. And that's the first term. Look carefully and see if you agree. Everywhere I see n, I plug n plus 1. Just a second. Look carefully and see if you agree. Is everything correct? So I was observing Ms. Gong. Several of you have asked about her in Calculus 3 class. And observing her teaching, evaluating her teaching, because I like to go and observe teaching and give some feedback for teachers to be better teachers. So she was actually a pretty good teacher, so I like her in Calculus 3 class. But what I noticed what she does, she finishes her statistics class or Calculus 3 class, any kind of example, when she finishes, like, okay, all agree? Is it good? People like, yeah, and keep writing. And she's like looking slow. And she's a Chinese small lady, and she's like looking everywhere. She's like, I'm sad. And she doesn't change face expression. It's very interesting. And I'm like, what? And then students now know, because they got used to that, it means there's a mistake there. She's like, keep looking, everyone, all agree? I'm sad. And people are like, okay, something is wrong. She's like, okay, but what is wrong? Well, we don't know. You just said that you're sad. That means something is wrong. And then they tell her what's wrong. And she's like, I'm happy now. And she keeps, it was so cute. I was like, wow, she's such a high-level PhD professional. She published like 6-7 articles per year, and she does work with Nissan and other companies to develop automatic cars using AI and huge hardcore partial differential equations. But then the way she said it was so funny. So, do you see the mistake? 2n plus 2. So should I write 2n plus 2?
Oh,
2n plus 2 plus 7. Okay, I can see what you're going to. It is correct. Let me ask more people. More people, more opinions, yes? I would put parentheses, so you do exactly the same thing, but you're already distributing. Did you notice that you need to put parentheses here? I see this mistake on the final example at times, so we'll try to bring it up as often as possible. Note, so like here, 2n plus 1 is not the same thing as 2n plus 1 with parentheses. Many of you don't have good habit, put parentheses, and that makes mistakes. So the second one is, so the first one, for example, that's 2n plus 2, easy peasy, keep moving, and you have a wrong answer. The second one is 2n plus 2 plus 1. See, that's not the same thing. The second one is 2n plus 3. Make sense? So make sure you don't forget parentheses. Yes?
The bottom right there, plus 1 plus 1, that's fine.
This, yeah, I'm talking about this one, exactly, this one. Oh, that one I will simplify later, yeah. That one is not that bad. So maybe check out, make sure you understand. Versus. Not the same thing. So just reviewing that. Oh, now I don't have space. Now you just copy the original fraction, but flip it. Do it while I'm doing this. Do it by yourself. Copy the original fraction and flip it. Let me put this in blue. Number 1 versus number 2. Versus means comparing, just letting people know, just in case. So I'm taking the original fraction, which was 9 to the n, and I put it in the denominator, n plus 1, 5 to n plus 1. See, I just flip it. Put absolute value. You don't need absolute value for this example, but you will need for others. So it's just nice to put it everywhere, just in case. But if you do understand when you don't need it, it's not a mistake to drop it. Limit n goes to infinity. What I'm recommending to do is to simplify and collect the terms that look alike. That's just smart. It will help you to simplify faster. So the first, I will collect the exponential functions together. 9 to the n plus 1 over what? 9 to the n, thank you. Then I will collect 5s, for example, but order doesn't matter, you choose what to collect. Let's collect 5s. 5 to n plus 1 over what? 5 to the what? 2n plus 3, thank you. Distribute. 2n plus 1 is 2n plus 2 plus 1. Finally, don't do anything weird with n plus 1 over n plus 2. You don't simplify this. Well, you can add numbers, but you don't cancel them out. That's wrong. Now, your job is to simplify exponential functions as much as you can. What gives you 9, after you simplify 9 to the n plus 1 over 9 to the n? That's just 9. What gives you 5 to the n plus 1 over 5 to the n, 2n plus 1 versus 2n plus 3? Who knows? People at the back, don't get distracted, don't get sleepy. See, I should yell louder so I'll wake you up at the end. What will be here? 2n plus 1, so 5 to the 2n plus 1 over 5 to the 2n plus 3. 5 to the 2, but where? Denominator, the bottom, exactly. So that is how I simplify exponents. I can review it for you if you want. N plus 1 and n plus 2 are not simplified here, so we're not going to simplify them. There's nothing you can do about additions or differences. And now the limit actually works now. For you to know, there are two constants here, 9 and 1 over 25, which is 5 squared. And then n plus 1 and n plus 2 is the only variable, n goes to infinity. So only this part is actually moving somewhere and has a limit. What limit is that? 1. So you have 9 times 1 over 5 squared times 1. And that is the answer, which is 9 over 25. That's not important. I don't care it's 9 over 25, 17 over 100, I don't know, 1 million over 35. What I care is if this is final answer, is it greater than 1 or less than 1? So that's interesting. That final answer doesn't give me the convergence number. We don't converge to that number. So the previous example we had, the answer was 0. Series does not converge to 0. We said series converges absolutely, but actually we never ask you to find converges to what. We're going to stop asking you this question for a while. Now we just care if it converges or doesn't converge. So that's it. So here I just care if this number in the test, we're testing the series. If this number is less than 1 or greater than 1, it is less than 1. That's what I need to know. It doesn't converge to 9 over 25. It's just a test, and test show me it's less than 1. Answer. Answer. L is less than 1. I don't even need to write down what L was. Then or thus, this series converges absolutely. Converges absolutely. And we don't even tell converges to what. That's actually a pretty important thing to point out. Converges absolutely. Let me write it down once, the word absolutely, but usually I don't do it. Absolutely. Mathematicians know this phrase really well, and engineers too, most of them. So if you write down converges abs, usually people know what it is. Converges absolutely means that the series converges with absolute values and without them. So let's see again. The series converges. So the theorem says, the theorem is a ratio test. The ratio test says not only the series converges, but it also converges absolutely, which means you can add IA, the series with absolute value converge. These converge with absolute value. That's the definition. That's the definition. Let me do like so. That's the definition of the absolute convergence. So let me once explain it to you. Usually we don't ask these questions in the homework, but note, the series with the, what was the original one? 9 to the n. 9 to the n over n plus 1 over, I should have make a bigger fraction line, over 5 to the 2n plus 1. 5 to the 2n plus 1. Put absolute value, so this one converges. And the original one converges too. That's what it means to converge absolutely. Also converges. So that is the definition of absolute convergence. Absolute convergence. It means converges with absolute values and without absolute values. As you can see, I don't even put from where to where, but actually it is from 1 to infinity. Check out one more notation. I don't remember if I show you or not. 1 to infinity, we don't actually always write down the counter. If it's only one counter n, then it's obvious it will be n. So some people save time and they don't do it. That is the idea. What do you think about this? Not too bad. Finally, let's do one more example. That one is from your homework, so that should motivate you to wake up. Wake up, people! One more homework problem. This is number 5, I think. Example 3, probably. What if we have everything? let's see. Oh, actually, it's still just lots of polynomials. It's fine. Minus 1 to the n plus 1. A to the n minus 1 all over 7 to the n plus 2. And also all over n plus 2 cubed. Like this. That is your homework problem. It's not as scary as you think, actually. Mostly it's algebra and then actual calculus. But that's the thing what scares people a lot, the algebra part. So I will not gonna perform the divergence test. Let's just jump into the ratio test. Solution. Ratio test. Should I read? Minus 1 n plus to the n plus 1. 8 to the n minus 1. N plus 2 cube. 7n plus 2. Make sense? The L will be, let's do capital L. Capital L equals limit n goes to infinity. And I'll right away start writing down n plus 1 term. N plus 1 term, everywhere you see n, you put n plus 1. So it's going to be, well, let me see if I should show you this or not. So I want to show you how to do it faster. I guess let me show you, and then I'll explain that it's not necessary. N becomes n plus 1. So it's n plus 1 plus 1. Right? The thing is, nobody cares about this part. This is such a waste of time. And they showed in the book, and they showed in solutions. It's absolute value. Absolute value exists exactly for one reason. Not to care about negative 1 sign. So even talking about this wastes your time. Absolute value is standing there to kick out minus 1. It's not needed. Because absolute value of minus 1 to any power, guess what it is? 1. So I usually don't write it down at all. Nobody cares. So I kind of try to tell you that you should not waste your time and space writing negative 1's powers. What you should do spend time is to figure out 8 part. 8 n minus 1 becomes 8 plus 1 minus 1. Over n plus 2 becomes n plus 1 plus 2 cubed. Finally, 7n plus 2 becomes n plus 1 plus 2. N is a counter, and right now we're checking what's happening at n plus 2. Times, I am copying the original fraction, but I'm flipping everything. N plus 2 cubed goes to the numerator. 7n plus 2 goes to the denominator. This minus 1 thing, I will copy it only once for today. N plus 2 denominator, 8, n minus 1 denominator. Because of the absolute value, we don't care about negative 1s. Like, just don't even waste your time on this. And when I see it in the book, they keep consistently writing it down. But why? Absolute value of negative 1 is 1. Why would you do that? Okay, after this, the idea is exactly the same. So you can finish this homework tonight. Because it's like all consistently the same. Which is, collect the terms that look alike. What should I put first? Who wants to tell me? People at the very back. People with laptops. Are you doing some investment? That's what I usually ask business students. What are you doing in the laptop? Are you investing? Stock market is open? Some of them actually do. I saw one business student ordering a tie from the Amazon during the class. So, like, you know, priorities. Calculus, ordering the tie. 8 to what? N, because plus 1 minus 1 gives you 0. So convenient. Let's put 8 at the bottom too. What power should be at the bottom? N minus 1, thank you. Times, you choose whatever you want to do now. For example, n plus 2 cubed. It's just next in order, but actually I would do 7. And the denominator, what should I put? What should I put in the denominator? N plus 3 cubed. And the last one is left 7. 7n plus 2 over 7n plus 3. I just calculated all those cute little numbers. Simplify. N goes to infinity. What does 8 to the n over 8 to the n minus 1 give you? Just What? 8. Right? 1 over 8 or 8? 8. Times, don't touch these guys. That will be part of the limit to figure out. You cannot cancel them out or factor anyway. It's good like this. How about 7? What's happening with 7? 1 over 7. The limit follows after this. There are two constants and a variable, n plus 2 cube over n plus 3 cube gives you a limit. What limit is that? So just let me tell you. No, I don't like this color. So not important stuff. 8 and 1/7. Just kick it out. 8 and 1/7. N is moving somewhere, but 8 and 1/7 are constant, so they don't move anywhere. They stay 8 and 1/7. That's why they're called constant. Times. Do you know the movie Constantine? So Constantine is a name. Kostya. Constantine means constant or reliable or like the same. So it's actually a name. N plus 2 cube over n plus 3 cube gives you a limit, and I can write down ones if you don't remember this. It's n cube over n cube. Like so, which is 1. So it's 8 times 1/7 times 1, which is 8 over 7. So maybe explain the limit a little bit more. I don't know. It depends how much you remember. Find the leader of the top. N cube will have the highest power. Other stuff, you just kind of like, you don't care about them. Because a limit at infinity, a polynomial at infinity is like a comet. The comet is flying in the space and has a tail. The tail follows the head. So we only care about the hat. N cube is the hat. N cube is the hat as well. We keep them. They cancel out conveniently. The answer will be the ratio of the leading coefficient, which is 1. So what is the answer? Diverges? I thought it converges to 8 over 7. No? Ratio test just gives you the test. The test says, I don't care it's 8 over 7. What I care it's greater than 1. So answer. L is greater than 1. Then, by the ratio test, the original series diverges. Diverges. Or it's called divergent test. It's a divergent test. One more thing to mention before this, but let me ask first. Did you get the divergent idea? Why is divergent? Because L end up to be big. Imagine all numbers end up to be 8 over 7, 8 over 7. So it's like 7.9 over 7, or 8 over 6.9, or 7.9 over 6. Anyway, all the ratios becoming a fraction that is greater than 1. Of course, you add them together, it blows up. So it makes sense. If it's greater than 1, everything blows up. Make sense? Let's think about the factorials, which we'll be using a lot on Friday. Wanted to mention that. Just note again. Note about factorials. So n factorial is 1 times 2 times 3 times and so on, some n. There's one exception of 0 factorial. What does 0 factorial mean? Nuh-uh. People decide to choose. So sometimes mathematicians just make a choice to be consistent. And to be consistent, they chose this to be 1. 0 factorial is 1. It just was made a choice to make sense of the set of factorials. Then 1 factorials is also 1. But 2 factorials is 2 times 1. And 3 factorials, it's 3 times 2 times 1. And so on. So the most important is remember, these two things are very important. And here's a joke about this. So last 5 seconds is an anecdote. It only makes sense in Russian, so I'll try to explain to you. There was a very funny Russian show called Students. And it was a show about students in some Russian university. It was hilarious. I really liked it. So the professor is teaching factorials, and we do call people to the board to actually answer questions and give them grades on the floor, which is very stressful. Lots of embarrassment is happening. So the professor asks, who remember what is 0 factorial? And then says, Jacob, come in. Jacob comes in, and he has no idea what you're talking about. He skipped the lecture. He never watched the video, no book. So he said, he's like, what? What is 0 factorial? And the teacher got distracted, and there was a book open. So Jacob looks at the book and is like, oh, it's 1. It's like, correct, but why are you so excited? Well, he says, well, because it's O exclamation mark equals to 1. That makes sense in Russian, but in English you put OH, right? So he was excited because in Russian it means, oh, it's 1. And that's how he accidentally gave away. He doesn't know what factorial is. It's a very good joke, okay? It's a very good joke. I promise you. That's good for today. You can start your homework. See you on Friday.